Welcome to our special interview on Pyrolobus fumari, an extremophile with a unique perspective on life in extreme conditions. Let me introduce today's guest, Pyrolobus fumari, a thermophilic extremophile that lives in the most extreme environments on Earth.
Hello everyone, my name is Pyrolobus fumari. I am a single-celled microorganism that belongs to part of the extremophilic archaea. I was first discovered in 1997 in a hydrothermal vent at the mid-Atlantic ridge beneath the Atlantic Ocean.
As it was mentioned in your self-introduction, can you explain to us in what way is life form extreme?
Certainly. For me, I was known for my ability to live under extremely high temperature conditions, which makes me one of the most heat-tolerant organisms known to science. I could thrive in temperatures ranging from 90 to 113 degrees Celsius. As extremophiles, we flourish in environments that are unbearably hostile or even lethal to other terrestrial life forms. Some of us can flourish in acidic and basic environments, such as niches with high temperatures, ice, or saline solution and toxic waste. We are also found in organic solvents, heavy metals, and various other habitats that were once deemed unsuitable for life. Nevertheless, life forms are exceptional in that they have developed the capacity to survive in conditions that are considered lethal to the majority of other life forms. This enables us to flourish in environments that would otherwise be fatal to other life forms.
Moving on to the next question, does the life form prefer an extreme environment, or can it simply just survive in extreme conditions?
Extremophiles are divided into two different categories: extremophilic organisms and extremotolerant organisms. Extremophilic organisms are those that prefer one or more extreme conditions over normal conditions. Thermotolerant organisms, on the other hand, can tolerate extreme values of one or more physicochemical parameters while still thriving. Therefore, the ability of organisms to thrive in extreme environments and potentially even prefer such conditions varies depending on the particular life form. While some organisms possess greater adaptability and can endure in a broad spectrum of environments, including extreme conditions. What aspects of the extremophile's biology allow for its survival in an extreme environment? Organisms like us have developed protections to survive in harsh environments. Almost all prokaryotes have a cell wall, a protective structure that allows them to survive in hypertonic and hypotonic water conditions. Some soil bacteria are able to form heat and drought-resistant endospores, allowing the organisms to survive until favorable conditions return. These and other adaptations allow bacteria to remain the most abundant life form in all terrestrial and aquatic ecosystems. For example, some extremophiles harbor distinctive biomolecules that maintain a comparatively stable state at extremely high temperatures, thereby facilitating uninterrupted metabolic reactions.
Our last question, what does this extremophile tell us about life beyond Earth?
My existence expanded the understanding of the extremes under which life can exist and has implications for astrobiology, suggesting that similar extremophiles might be able to survive in the extreme conditions found on other planets or moons in our solar system. We also help to gain a better grasp of the circumstances necessary for habitability from the presence of extremophiles. Previously considered hostile circumstances, such severe heat may really be hospitable to life according to this idea. This expands the potential spectrum of planetary worlds outside of our solar system that may support life, such as learning about how to build space missions and where to look for signs of life in the universe from the traits and adaptations of extremophiles.
Thank you for exploring extremophiles with me, and thank you Pyrolobus fumari for joining us. See you next time.